Figure 4 shows a sketch of the curve C with equation y equals 5x to the power of 3 over 2 minus 9x plus 11, x is greater than or equal to 0. The point P with coordinates 4, 15 lies on C. The line L is the tangent to C at the point P. The region R, shown shaded in figure 4, is bounded by the curve C, the line L and the y-axis. Show that the area of R is 24, making your method clear. So the first thing we would want to do here is recognise that because the line L and the curve C cross, or the line L is the tangent to C, at the point P, which happens at an x coordinate of 4 and a y coordinate of 15, if we just write the coordinates as 4, 15 here. Because the line L is a tangent to C at the point P, what this means is that at the point P, the curve C and the line L have the same gradient. So if we find this gradient that is the same for both of them, then we can find an equation for the line L, because we already have a point that the line L crosses through, 4, 15, and a gradient means that we can find the equation of the line. So if we go to do this, we want to find the gradient of C at 4, 15, because we know it's the same for L. So to find the gradient of a curve, we would want to differentiate the equation of the curve, which is this one here. So if we differentiate this, we say that dy by dx is equal to, and now for 5x to the power of 3 over 2, we multiply the 5 by the 3 over 2, so we multiply the coefficient of x by the power, and get 15 divided by 2, x, and then we take away 1 from the power, so 3 over 2 take away 1 is a half, and then we do the exact same for all the others, so minus 9x is the same as minus 9x to the power of 1, so minus 9 times the power, so minus 9 times 1 is still minus 9, but then we have x to the power of 1 take away 0, which is x to the power of 0, which is the same as 1, so it is just minus 9, and we do the same thing for 11, and we end up with 0, so we can leave it at this. So to find the gradient at the point P, we want to find this gradient when x is equal to 4, because that is the coordinates that we've been given. So at x is equal to 4, the gradient is 15 over 2 multiplied by 4 to the power of a half minus 9. And if we put this into our calculator, we find that the gradient is 6. So now for the line L, we know that its gradient is 6 and it passes through a point 4, 15. So if we use the equation of a straight line, which is y minus y1 is equal to m, the gradient, bracket x minus x1. And if we put it into this equation, we find where y1 is 15, m is 6, and x1 is 4. And we rearrange it, we find that y minus 15 is equal to 6x minus 24, and therefore y is equal to 6x minus 9. So we now have the equation of the line L and the curve C. And what we can do with these two equations is we can actually integrate. So if we look back up at the graph from before, we know that integrating is finding the area under a curve. So if we integrated between 0 and 4 for the curve L, we would actually get this area under here. And if similarly, if we integrated between 0 and 4 but for the curve L, we would get this area here as well as a negative form of this area under the x-axis. And the reason it's negative is because its y-coordinates are negative. So for example, if the area of that small triangle was 2, integrating would give us minus 2. Now you may be able to see here that all the bits that were in yellow that we didn't want, that weren't part of R, were then highlighted in purple, and the one bit that we did need to add to this to find R is the bit under the x-axis that would come out as a negative value. So you may be able to see that therefore, if we were to integrate the equation of the curve C, if we integrated that between 0 and 4, and then took away from that the integration between 0 and 4 again of the line L, we would actually find the area R, and that's because it would take away this big rectangle, triangle that we have here. It would take that away from our area, and it would also add on this small triangle here. And the reason it would add on is because if we're taking away a negative, this leads to addition. So if we go and do this, and we integrate between the limits of 4 and 0, the curve C, which has equation 5x to the power of 3 over 2 minus 9x plus 11, and then we're taking away from that the same thing, integrating between the limits of 4 and 0, but this time just the equation of L, which we have just found to be 6x minus 9. So if, first of all, we concentrate on integrating the curve C, so to integrate, we add 1 to the power, so adding 1 to 3 over 2 gives us 5 over 2, and then we do 5 divided by 5 over 2, divide the coefficient by the power, so we're left with 2x to the power of 5 over 2 minus 9 over 2x to the power of 2, doing the exact same thing, and 11x, and this is all still between the limits of 4 and 0. And now if we go back to the line L, integrating 6x minus 9 gives us 6 divided by 2, which is 3x squared, minus 9x between 4 and 0 again. So now what we do is we substitute in firstly 4 for x, and then take away substituting in 0 for x. So 2 times by 4 to the power of 5 over 2 minus 9 over 2 multiplied by 4 squared plus 11 multiplied by 4. And then this is take away 0 being substituted in for all of these x values. But what we can see is, since these are all numbers multiplied by x, if x is 0, these are all numbers multiplied by 0, which gives us 0. So we can write minus 0, but we don't need to write out the whole thing. And now what we do, if we want to take the line L, is we do the exact same thing. So 3 times by 4 squared minus 9 multiplied by 4. And then we have the same problem, which is that substituting in 0 just gives us 0 again. So we don't need to write that out again. And we're left with this. So now if we do some calculations, putting the first sum into our calculator gives us 36. And then 36 take away 0 is just 36 still. And then the integration of line L gives us 12. So we're taking away 12. And this leaves us with 24, which if we scroll back up to the question, is what we were asked to show. So we can conclude with saying that the area of R is 24, and we don't know units, so we can't give a unit squared. So there's quite a lot of marks up for this question, 10 marks. So our first mark comes from differentiating the equation of curve C to give us this. So we get a method mark and an answer mark, so this should be 2 marks, just for differentiating this. And then we get a further method mark for substituting in x equals 4 and finding that the gradient is 6. We then get another mark for finding that the equation for line L is y equals 6x minus 9, and the actual method we use for solving that. So we get 2 marks for using this method and then actually giving the right answer for this. We get a further method mark now for saying that the area of R is equal to, and then this big formula here we have of integration. We get a method mark for writing that out, and then a further answer mark for solving it, more specifically getting this bit right of the integration, because that's the more challenging part. So that's another answer mark there. And then actually solving the equation gives us a further method mark. And then our second to last mark is our answer mark, so showing that the area of R is indeed equal to 24. And we actually get our last mark for just having the correct notation and like fully explaining our answer through our working. So showing a full working out with the correct notation actually gives us our last mark.